Hello guys, today our group want to present about mini project for data structure. So let's me introduce myself first. My name is Mohamad HELMI NAIM bin Muhammad ROSLAN and my matrix number is 10DDT21F1072. So for question 1 is list and linked list. A linked list is a linear data structure where each element is a separate object. Figure A is an example of the types of linked list. So, by referring the YouTube link, use figure A to explain about insertion and deletion operation of linked list. So, I will discuss some about deletion operation and insertion operation. For deletion operation, if we want to delete the node with data 30, we have to first consider its previous and succeeding node. Then deletion would be simple if make the node with data 20 point to the node with data 40. We will the fact it exclude node 30. The node with data 30 will still be in the memory, but it is out of the list. We can use delete to dislocate it. Deletion program is to locate the previous node of the node to be deleted. So, next is insertion operation. For insertion operation, we want to insert a node with data 28 before the node with data 30 and after node 20. So, the next node for 20 is 40. This should become 28. And to maintain the continuity, the next node of the inserted node 28 should be 30. So the next question will be continued by Haris Hakimi. Thank you.
Good morning to my beloved lecturer. My name is Muhammad HAKIMI bin BASIR and my metric number is 10DDT21F1086. First and foremost, today I will solve question 2. There is stack. And firstly, we need to create a stack with containing 5 elements in the stack, which is COVID. Then we pop stack 3 times and insert or enqueue the element into a queue that is contain div elements. After that, 2 elements that are deleted from the queue or the queue are pushed back into the stack, making the stack now is CODI and Q is V. For the last step, one item is popped from the stack, making the last item in the stack is COD. And for the pop element that was happened is DIVI. Thank you. The next question is presented by Helmi Naim.
So for question 3 will be presented by me. So question number 3 is Q question. I made the answer in the form of circular queue. First of all, I create circuit P. Then I enqueue A into the circuit index 0. Then for front and rear is A. Next, I enqueue 15 into the circuit index 1. Then the front is A and the rear is 50. Next, the question are DQ. So we DQ index 0, which is the element is A. So the front is changed to 15 and rear are also at 15. Next, I NQ 5 into the circuit index 2. So the front is 15 and the rear are changed to 5. So that's all from me. The next question will be presented by AISY. Thank you.
Hello everyone, my name is Muhammad HAFIY bin Muhammad RASUL and my metric number is 10DDT21F1080. I will continue the presentation and explain about question 4. The question is, use the tree traversal in figure 2 to write the preorder and in order traversal further following expression 3 in figure C. Okay, firstly, I will explain how I do for pre-order traversal. For pre-order traversal, we only need one visit for each node to write down the output. So let me show how I do. Firstly, we start the traversal from root and visit it. So we write down 1 in the output. And then we continue and visit 2 and write down the output. And then visit 4, write down. After that, loop and visit 4 again. But don't write the output because we only need one output per node. That means if the node already in the output, don't write again or twice. After that, we visit 2 again and check if 2 already write. If already, so don't write again. Next, we visit 5 and write down the output. After that, we visit 7 and same write the output. Next, we look at 7 and 7 already in the output, so don't write again. Next, 5, same, already write. After that, we visit 1 again and 1 already in output. Next, we visit 3 and write the output. Next, we visit 6 and same, write the output. After that, visit 8 for the first time and write the output. So if we already write all the node in the output, that means we already finish our traversal. So the output is 1, 2, 4, 5, 7, 3, 6, and 8. Secondly, I will show how I do in order traversal. For in order traversal, we need to visit the node twice for we to write the output. Okay, let's begin the traversal. Same to the pre-order, we start with root and visit 1. So this is the first time we visit the node. So we can't write yet. This node for the output. So let's continue after that, we visit 2 for the first time. And same, we can write yet. Next, we visit 4. Same, we can write for the first time, we visit. After that, we look at 4. And this is the second time we visit. So we can write this node in the output. Next, we visit 2 for the second time. So we can write it in the output. After that, we visit 5 for the first time. So can't write yet. Next, we visit 7 for the first time. We can write. And then look at 7 and visit 7 for the second time. So we write 8. After that, we visit 5 again and write it in the output. Then we visit 2 for the third time. And 2 already write in the output. So just move to the next node, which is 1. And this is the second time we visit 1. So we write 8. After that, we visit 3 for the first time. So we write yet. We can't write yet. Next, we visit 6 for the first time. Same, we can write 8 again. Next, 8. First time, same, can't yet. After that, we look at 8 and visit 8 for the second time, so we can write 8. Next, 6 for the second time. And we write 8 in the output. And then we visit 3 for the second time. And we can write 8. So we finish write all the node in the output. That means we'll finish this in order traversal and the output is 4, 2, 7, 5, 1, 8, 6, 3. Next, I will present about the question 5. In this question 5, for what box we put apple, books, crayon. For where box, we put school, store, and park. And who box we put doctor, teacher, and baby. To help students differentiate between the type of simple question, I often use a sorting activity. This activity work everywhere on my formatted active panel, where students can drag the picture to the appropriate column. I also send home the hard copy for practice using verbal response or to use as a cut and paste activity as in figure C. Next. Next question is calibrate 4 factors that could be reviewed before choosing sorting algorithm that is suitable to use this scenario. The first thing is simplicity. Simplicity of implementation usually has nothing to say when it's come to factor like performance and speed. Algorithms like insertion, sort are easy to understand and implement. They are used for education purpose, small size data, and real life scenario. For example, employee will choose insertion sort to organize crayon, apple, and books based on their type. The second one is memory consumption. Space complexity state how much memory is being used regarding to size of input data. Some basic algorithm like bubble sort require no addition memory and can sort the data in place. It compare all the element one by one and sort them based on their value. For example, using bubble sort to sort type of apple and crayon brand. Next, Haris will continue presentation. Thank you.
The third one is fast. Using Quicksort is a highly efficient sorting algorithm and is based on partitioning of array of data into smaller array. This algorithm is quite efficient for large size data sets. For example, most management will use Quicksort to sort doctor, teacher, and baby name so they can find them easily. The last one is parallel processing. In real-world scenario, terabytes of data still need to be sorted in a resourceful way. Procuring super strong machine is not feasible due to significant cost. Instead, data can be divided and assigned to cheaper machine to sort independently and then merge later to create final sorted result. Algorithm that incorporate divide and conquer approach such as merge sort are good candidates to be used in parallel processing. For example, using merge sort to merge two types such as people and place together. And that's it from my team. Thank you. See you guys in next live.